So we know tolerances are needed, but how are they defined? Where do they come from? Well, there's several ways in which tolerances can be determined. Some instances of these are from existing parts. Let's say a part is being updated with a new feature, but it's been in production for years. The assembly team may already have stable processes in place that produce repeatable results. This existing knowledge can be used to ensure the tolerances on the new feature are manufacturable, and make sure that they're not too tight or too loose. Engineering knowledge references can also be used to determine tolerances. There are many references available to help with tolerance selections. One of the most important and most common is the Machinist's Handbook. Let's say we want to know how to tolerance a hole for a close fit around a 1/2-inch bolt. Well, we can look up in our Machinist's Handbook and see that here on this page, we have the recommended tolerance limits for this hole. In this case, there's a reference that dictates what a standard tolerance should be for these types of holes, and they're very useful references to have. Next, we have scientific principles or studies. This is basically any type of test that we're running on the part to make sure it works to begin with. Using these studies, cycle tests, or prototypes is an excellent and accurate way to test tolerances. It also allows early designs to adjust as necessary to make sure when they get into production, they work as intended. And finally, the last, and probably the most common, is just from professional experience. Using professional experience is another method of applying tolerances. Over time, one will tend to learn what works and what doesn't for their specific applications. This doesn't just apply to design, too. Manufacturing engineers and machinists will also understand what limits their machines can hold and how tight of tolerances their parts can allow. Now, as a rule of thumb for design, tolerances should be kept as large as possible while maintaining the part function. We want to have the tolerance necessary for the part to work without making it any tighter. Tight tolerances increase manufacturing cost. Therefore, money is wasted when tight tolerances are used if they are not functionally required. Now, before we continue talking about dimensional tolerances, an important thing to remember is that tolerances don't necessarily have to be dimensional. Very commonly, you will find these types of dimensional tolerances on your print, like this. However, you may also see geometric tolerances, which look like this right here. Another form of tolerances are force or load tolerances. You can see that in this note right here that we have a specific tolerance on the spring rate. We also have test criteria tolerances, which dictate exactly where the part needs to fall within a specific test during the inspection process. You can see that there are 4 different types of tolerances on this drawing alone, and it's important to understand that all we're doing is placing limits so that we know what is acceptable and what we need to reject. So let's do a quick review on the basics of tolerances. Parts can never be made perfect, so to limit the variation, we apply tolerances. A tolerance is the acceptable range of variation that still allows for proper function. We use tolerances to clarify part limits, convey critical dimensions, and ensure function or assembly with other parts. Remember, in some cases, these are legal requirements for a contract. Another note is it is always important to have tolerances that are required for the function, but not any tighter than necessary. Remember, this adds additional cost. Tolerances can be defined in many ways. These can be from existing parts, engineering knowledge, professional experience, or scientific principles like studies and tests. There are many different types of tolerances. They can be physical, which are probably the most common, the dimensional tolerances you see, geometric, performance-based, like force requirements, inspection or test criteria, such as specific tests that we have on the part, or any other type of limit that we're putting on this part. Tolerances don't necessarily have to be dimensional, but remember, everything has a tolerance.